Good afternoon, everyone. Today we're going to do a video on graphing linear functions. So this is for Math 8. We're in the graph on one side in black, the equation y is equal to 2x minus 3, and here in red we're going to graph y is equal to x minus 1 and look at the similarities and differences between the two functions. So here's our graph. Let's start off by completing our table of values. And so for these predetermined values of x, x are independent variable. And so since independent of y, we get to pick whatever values we want to look at. We get to choose whatever 5 values we want to look at. The magic number is typically 5 for the number of values that we want, so that we get a nice idea of what the points look like when they're put onto a graph. And so I typically go from -2 to +2. Those are the most central 5 values of x, and so it gives us a nice idea of what the middle of the graph is, rather than going out into the edges of the graph. So let's go ahead and pop each of the x values into our equation. So for example, if we start with x being -2, then we're going to place this value into our equation and get our value of y. So y is equal to, instead of x, we have now -2 minus 1, and -2 minus 1 is -3. And so that's what we get for y. Okay? We can do that for all values, but I typically ask my students to show 3 calculations, just so that we see that they can evaluate the function, and then from that point on, we can use a pattern to kind of finish our table values, understanding that these are linear functions. And so the change is going to be always the same. Okay? So let's do the second value when x is equal to -1. We get that y is equal to -1. I always put my values in brackets when I'm substituting them in for a variable. That just kind of lets me know what I'm doing. And so -1 for x, -1, and -1 minus 1 surely gives us -2. And then you can imagine when x is equal to 0, y is equal to 0 minus 1, which is -1. And at this point, once we've shown 3 calculations, and we've shown that we can evaluate a function, we can kind of look at the pattern. So here, our coefficient of x, that is the number in front of the x, is 1, because there's no number there. But if there's just x by itself, we assume that it implies, we know that it implies that the coefficient is 1. There's 1x there. Okay, there's not 0 x's. If there were 0 x's, there would be nothing at all. It would just be -1. So if there's an x by itself, it's implied that it's 1x. And so the coefficient of x determines the constant change in the y values. So if the x values steadily increase by 1, then our y values are going to increase by our coefficient. And that's +1 as well. Okay. And then the second part of our function, this -1 at the end, this is called our constant term. It's called our constant term because it's constantly -1. There's no variable in it, so it can't change, it can't vary. However, the first term is some number, a coefficient, times x. And since x is a variable, that means it's able to vary. This term varies all the time. It varies with the value of x. But the -1 is constantly -1. And so that's our constant term. And we get this term by looking at the y value when x is equal to 0. Because when x is equal to 0, that first term is going to be the coefficient, some number, times 0. And anything times 0 is 0. And so all we have left is 0 minus 1, or 0 and the constant term, whatever that might be. And so when x is equal to 0, this term is 0, and so all we have left is the constant term for the y value. So if we're looking for the constant term by looking at the table of values, we can look at the value of y when x is equal to 0, and we know that's our constant term. Okay? And so now we know that the values are going to steadily increase by 1, and so -1 plus 1 is 0, and 0 plus 1 is 1. And now we finally have our 5 points, so we can pop those onto a graph. Remember that our points are always written with coordinates x, y. That's conveniently how we've laid out our table of values. And so the first point is that x equals -2, y equals -3. Again, x always on our horizontal axis, y always on our vertical axis. So x being -2 is over here, and y is -3 is somewhere around here. -2, -4, -3 is in the middle. Okay? Let's write the coordinates just to be very, very clear. Next we have -1 and -2, so that's -1 -2. Next we have 0 and -1. That's x equals 0. 3, 2, 1. 0 is right smack dab on our vertical axis. And -1 for y is somewhere around here. Next we have 1 and 0, so that's 1 in x, 0 in y. Y is 0 smack dab on the horizontal x-axis, and so that's our fourth point. And then finally 2 and 1, that's 2 and 1. I'll write the coordinates just to be very clear. And it's a linear function. First 4 letters of the word linear make the word line, because figuratively our points make a nice straight line when we plot them on a graph. Okay? So because of our coefficient of 1, notice that every time the x value goes up by 1, our y value simultaneously goes up by 1 as well. That's because of our coefficient of 1. And so if we go on from any point on our line to the next one, we're going to go over by 1 in x. That means the x value increases by 1, right? Because the x values are along the horizontal axis. So if we go from x equals -2 to -1, we've increased by 1 in the x direction. Then we also increase by 1 in the y direction. And that's how we get to our next point. We go up by 1 in the y direction. So over by 1, up by 1. Over by 1, up by 1. And so on and so forth. And that's how we get successive points on our line that we could iterate forever and ever. Okay, and same backwards, except backwards we would go down 1 and back by 1. Okay, so it's just reverse going backwards. Okay, and so now let's compare that to our equation y is equal to 2x minus 3 here with a black marker. So if x is equal to -2, excuse me, we have x equals -2. We plug that into our equation and we get that y is equal to 2 times -2 minus 3, which is -4 minus 3, being -7. Next on, we have x equals -1. Again, we get to choose the 5 values of x we want to look at. I'm choosing -2 to +2, so we can easily compare them to our first function, and that they're the most central 5 values on our graph. I don't want to go too far on the edges. I like to keep things central. We could similarly choose 0, 1, 2, 3, 4, any 5 values you really want to. I just think these are the most convenient to look at. Okay, but we have complete freedom since we're looking at our independent variable for x. Okay, so when x is equal to -1, y is equal to 2 times -1 minus 3, being -2 minus 3, being -5. And let's do 1/3 calculation, because often we're asked for 3 calculations, and so y is equal to 2 times 0 minus 3. This is where we get that constant term, because when x is equal to 0, this first term is 0. And so all we're left with is that last part, which is our constant term. And so -3 when x equals 0, y is equal to -3, exactly our constant term. Likewise, -1 when x equals 0 was our constant term. Okay, that's going to be consistently the case whenever we're looking for linear functions and for all polynomials, which you'll see later on. So now we have 3 calculations shown. Now we can look at our coefficient of x. Our coefficient of x is 2, telling us that as x values increase by 1, our y values increase by 2. They increase by the coefficient of x. And so the y values increase by 2. And with this in mind, we can finish off our table of values. -3 plus 2 is -1. -1 plus another 2 is +1. And now we again remind ourselves that our constant term is the y value when x is equal to 0. -3, -3, checks out. Okay? Now let's plot these points. So we have first off -2 and -7, always in the form of x comma y, so -2 and -7 is somewhere around here. -7 being around there. -1 and -5, somewhere around here. 0 and -3, so we're going to cross the y-axis at -3. Notice that we cross the y-axis right at the constant term. So we cross the y-axis with our line right at -3, at -3, and here we cross it in the first line at -1, at -1. Okay, that y-intercept is not a coincidence, it is always our constant term. So we have a point at 0, -3, then we have 1 and -1, and finally 2 and 1. So 2 and 1 is over here. So our 2 last points are actually identical. And so now go ahead and graph this line, we get something like this. And so if we wanted to be able to, one another later on, you're gonna find how to solve systems of equations. So these two lines would intersect at the point 2, 1, and so that would provide us a solution to a system of equations. However, we're not dealing with that quite yet, just a note for the future. But you might notice that this line is steeper than our first line, right? It's going up faster. It starts lower, but it goes up faster, and you can see it crosses at our point of intersection here, right? That is because of our coefficient, right? Our coefficient tells us how fast the y values change relative to the x values. Here, the y values only go up by 1 every time the x values go by 1. Conversely, over here, our y values go up by 2 every time our x values go up by 1. So this equation, you can think of it, goes up twice as fast as our first one. They have a different starting point, a y-intercept. Here we cross at -3, here we're saying -1. But the rate of change, right, the amount that we change every time here is twice as fast as that one. So in this case, when x goes up by 1, meaning that we go over by 1 in x, because the x direction is positive to the right, and so if x increases by 1, we travel over by 1 in x, we go up by 2 in y, and so that means we go up by 2. And we'll land on our next point on the line. Again, iterating that idea, over by 1, up by 2, over by 1, up by 2, and we can continue that process forever and ever, and we get all the points on our line. And so those are the big points of emphasis for linear functions. I hope this comparison was helpful to illustrate some of the important ideas. If you have any questions, comments, suggestions, please do let me know. Thank you so much for watching, and have a great day.